In this recording, I'll be helping you by giving you some tips on how to solve paper 2 questions. Now, with this paper, unlike paper 1, you are allowed with a calculator. You're also allowed with your data booklet. My first recommendation is to really get to know your data booklet, to know where everything is. Most of the time, the IB does, in its questions, tell you which page to look at or which section to look at to solve certain problems. But it's also a good idea for you to know where things are. So if you are stuck on a formula, you know exactly where to find it. The important thing with this paper is to understand what you are given. So a lot of the time, the information that you have is important. Like you need to learn to dissect the question and to know what you actually have. The reason why we start off with atomic structure, for example, when we start learning chemistry, is because once you understand the element that you're dealing with, you'll understand the type of bonding it's going to have based on its electronic structure, its valence electrons, etc. When you do have a compound, such as with this question, you need to understand what kind of bonding is happening. Once you understand the nature of the bonding, then you'll understand the nature of the reactivity. So keep these in mind as you read the questions. So let's go through the first question. So generally with most of the IB questions in paper 2, they have multiple parts and they're all going to answer the first statement here. So it's really important to dissect what you have because this is going to lead to follow-up questions after. So the question says, iron may be extracted from iron to sulfide, which is FeS. Just by reading this statement, I know that I have a metal. I know that its oxidation number is +2 because remember with metals you can have variable oxidation numbers especially if you have a transition metal. So this 2 in Roman numerals, that means that that's a charge of the metal. And I have a sulfide which gives me the formula FeS. Now this is going to be FeS because like we said iron is +2 and sulfur belongs to the same group as oxygen, so it must have a -2 charge. So knowing this, I have Fe2 plus and S2 minus, which gives me FeS, which is balanced. So I also know iron is a metal and sulfur is a non-metal. So here I also have an ionic bond. So I have an ionic compound. So I can keep these in mind while I start to answer the questions. So the first part is telling you outline why metals like iron can conduct electricity. So I need to go back to the metallic properties. What defines a metal? So what defines a metal is that you have cations surrounded by a sea of delocalized electrons. Now these delocalized electrons mean that they are moving, okay? And the sea, we say that it's a sea of delocalized electrons because we have a lot of electrons that are shared between the cation centers. So if we think about the cation centers, in this case being the iron, being the positive centers, then we have electrons freely flowing between them. And we know in order to have electricity, I must have a flow of electrons. And this is basically what causes electricity to happen. So these electrons are moving between the cation centers and they're free flowing, meaning that they're not stuck between a certain center. And this basically is the reason why we say that metals like iron can conduct electricity. So if I look into the mark scheme for that particular question, this is exactly what they want. They want to see that you're saying mobilized or mobile or delocalized sea of electrons. Either mobile or delocalized sea of electrons would give you the right answer. Let's look at the next question. Justify why sulfur is classified as a non-metal by giving 2 of its chemical properties. This is very important because a lot of students might confuse the difference between a chemical property and a physical property. Physical property is the way that a substance looks like or behaves based on its certain property. Chemical properties is all about reactivity. So basically, how does it react with other substances? So if I know I'm a non-metal, how does a non-metal react that gives it away as a non-metal? Okay, so why is sulfur is a non-metal based on the way that it reacts? So here the important thing is to recognize the difference between chemical properties and physical properties. Chemical properties are all to deal with reactivity. So what happens to this substance when I react it with something else? Whereas physical property is all to deal with the behavior of the substance as a result of its features. So for example, it's highly electronegative. it is lustrous, it is a gas, it's an odorless gas, things like that. So here they're specifically asking you, why is sulfur a non-metal based on its reactivity? Well, first of all, I know that sulfur belongs to the same group as oxygen, which means that it belongs to group 16. And I know that all group 16 elements are non-metals because what happens is when they react with metals, so metal with a non-metal, they're going to form an anion because a metal with a non-metal forms ionic compounds. So what's going to happen to the sulfur is it's going to take the electrons of the metal that it's reacting with, because you're going to get a complete transfer of electrons from the metal to the non-metal. Second of all, I know that sulfur is also a non-metal. So if a non-metal reacts with another non-metal, in this case, I'm going to have a covalent bond. And this covalent bond, depending on what the sulfur is reacting with, can be polar or it can be non-polar. So these are two examples of chemical properties of sulfur that classify it as a nonmetal. Other examples that you can include is that sulfur can form acidic oxides rather than basic oxides. You know that as we go across a period, when we start with the metal oxides, they're very basic in nature, things like sodium oxide, magnesium oxide, etc. And as we move across, these oxides become more acidic in nature. So when we have things like sulfur dioxide and sulfur trioxide, they're more acidic in nature. And this again classifies them as nonmetals. Another thing that you can talk about is that sulfur, again being in the same group as oxygen, is a strong oxidizing agent. This means it gets reduced when it reacts with another element that is readily oxidized. Now here with these mark schemes, to get a complete 2 marks for this question, you need to name 2 chemical properties. However, if you talk about things like being a non-conductor because it's a non-metal, or that it has a high ionization energy or high electronegativity or low electron affinity, if you answer 2 of these, then you get a maximum of 1 mark, okay? So it's very important, like I said, to recognize the difference between chemical properties and physical properties. This next part is going back to what I said before. A lot of the times that when you have a statement starting off the question, you need to dissect the question to get to the answer. So here, this is following on through the introductory statement that when you have iron to sulfide, that you're actually going to have an ionic bond. And I know that because iron is a metal and sulfur is a non-metal. So the question is asking you to describe the bonding in this type of solid. In other words, they want you to define this structure. And the first thing that you need to remember for any of the 3 main intramolecular bonding is that you need to focus on the point that these are electrostatic attractions. You must mention this. So they are electrostatic attractions, okay, between ions, so between anions and cations, okay? Now I know what my anions and cations are. My cation is Fe2+, okay? And my anion is my S2-. So you need to mention that they're electrostatic attractions between anions or cations. In this case, you know that it's the sulfide and the iron 2+. Okay, you can write cations or anions, it doesn't matter which order. And what's actually happening here is that the electrons from the iron are completely transferred to the sulfur, thus forming the ions. So if we go to the mark scheme here, you'll see that they want to see that you've talked about electrostatic attraction, and they need to see that you said either between oppositely charged ions or between the Fe2+ and the S2-. These are very important and you must mention them. Next question is going back to the electron configuration, and here you need to be careful that you're looking at the sulfide ion and not sulfur itself. So S2-. They want the electron configuration of S2-. So here again, you need to go to the periodic table, and then you know that sulfur belongs to the same group as oxygen, okay? And it has 16 electrons, so you would write that it has 16 electrons, and then you go and you find the electron configuration of sulfide. So I know that I have 16 electrons plus 2 because that's minus 2. So then you would write 1s2, 2s2, 2p6, 3s2, 3p, okay, 2, 4, 10, 11, 12. I need to get to 18. So what do I need? I need 6. So 2, 4, 10. 10 and 6 plus 2 is 18. And this gives you the electron configuration of the sulfide ion, which is this one here, okay? Now, this is really important that you will not be awarded any marks if you do the noble gas configuration or the condensed configuration, because the question is actually asking you for the full electron configuration of the sulfide ion. So again, here the important keynotes is that they want a full electron configuration and they want it of the sulfide ion. I know that sulfur has an atomic number of 16, but because I have 2 minus charge, that means I've gained 2 electrons, which gives me the noble gas configuration. Next question is telling you, outline in terms of the electronic structures why the ionic radius of the sulfide ion is greater than the oxide ion. So this is looking at periodicity. So I know that oxygen belongs to period 2, okay? And I know that sulfur belongs to period 3. So by nature, as I go down the group, I'm gaining more shells. So oxygen fills 2 shells, whereas sulfur fills 3 shells, hence why it belongs to period 3. So because of that, because I have more shells, then it's obvious that the sulfide ion is going to have a larger radius than the oxide ion. So here, why is the ionic radius of the sulfide ion greater than that of oxide ion? So there's different ways to approach it. I would approach it in the sense that it has more shells, okay? So I have more electrons, and then the electrons would basically want to spread out, which makes the size even bigger. So if we go to the mark scheme for that one, you'll see that it tells you that the valence electrons are further from the nucleus, or that you have an extra electron shell, or that the electrons are in the third shell, 3sp, 3p, not in the second, as in the oxygen. You can also talk about the electron arrangement. So when you have numbers and commas between them, this is your electron arrangement. So oxygen's electron arrangement is 2, 8, so 2 electrons in the first shell, 8 electrons in the second shell. Whereas for the sulfide ion, you can see that I filled 3 shells, 2, 8, 8. So any of these will be awarded the mark for that kind of question. But the important thing is to recognize that when we're looking at periodicity, it's always the distance from the nucleus to the outer shell. The bigger that distance, the bigger the size. The closer they are together, the smaller the size, okay? So obviously, as we go down a group, the size is going to be increasing because naturally we are increasing the number of shells. The next question is asking you to suggest why chemists find it convenient to classify bonding into ionic, covalent, and metallic. Now, this question is an open question and it's basically common sense. And it's getting you to think about why we classify things. We classify things because it makes it easier for us to understand properties, to make predictions, to generalize, etc. Which is exactly why we do that to the different types of bonds. In order to be able to say that this substance is going to behave in a certain way and make predictions about it, I need to know their properties. I need to know whether it forms ionic, covalent, or metallic bonds. I need to know whether you have a metal with a non-metal. I need to know if you have a non-metal with a non-metal, whether you're creating an alloy from different metals. Okay, so this one again is like a common sense question. For me, it's like making predictions or generalization, which is exactly here what they tell you, that you can say that you can allow them to explain the properties of different compounds or substances, enables you to generalize about substances, or enables you to make predictions. And you see here that they will accept any common sense answer. But to be on the safe side, you go back to the main reason why we as humans like to classify things is to basically get a better understanding of things and to generalize. Okay, the next question says, the first step in the extraction of iron from iron 2 sulfide is to roast it in air to form iron 3 oxide and sulfur dioxide. And then it asks you to write an equation for this reaction. Now, you need to understand that most of the time you have the answer of the equation in the actual question. So in order to extract iron, okay, so what I want to do is I want to extract iron from iron 2 sulfide is to roast it in air. And whenever I see the word air, I think about oxygen. So I need to roast it in air. That means I need to heat it up in air to form iron 3 oxide and sulfur dioxide. That is the first step. So that's basically your equation. It's telling you take iron sulfide, S, okay, and react it with oxygen, gas, in order to form iron 3 oxide. And they've given you that this is iron 3 oxide, okay, and I have iron 3, so this must be 3 and this must be 2. and this is a solid, and sulfur dioxide, which is going to be a gas. Okay, so iron sulfide is roasted in air, and air, the main component is oxygen, especially in chemistry. That's basically what it's reacting with to form iron 3 oxide and sulfur dioxide. If you're not sure how I got to this, you need to go back to ionic compounds. I know that I have Fe3 plus, and I know that the oxygen is always O2 minus. When you add the charges, you realize that these are not equal to 0. 3 minus 2 is going to be plus 1. That means I have an extra plus 1 charge. So the easiest way to balance these is assume I have one atom of each and then do the cross multiplication. So what I do then is 2 times 1 is 2 and 3 times 1 is 3. And this is basically how I get to the answer. Then the next part is basically to balance the equation. The first rule of balancing equations is to balance all atoms except hydrogen and oxygen. So I'll look at the iron here and the sulfur. Iron is not balanced. I have one iron here, I have 2, and the sulfur, I have 1 and 1. So I will start off with the iron. So that means I need 2 iron atoms here. So in order to balance, we know that we always change the coefficient. We never touch anything after the atom because that's basically changing the composition of the compound. So now I have 2 irons, but I also now need 2 sulfurs. So then I will put a 2 here. So now I know that the iron is balanced, the sulfur is balanced. I'm left with the oxygen. I have 2 oxygen atoms here, and here I would have 3 oxygen atoms and 4. So 3 plus 4 is 7. So if I do 7 over 2, then that would give me the answer. But knowing I don't like fractions, what I can do to get rid of this 2 is multiply the whole formula by 2. So then 2 times 2, that gives me 4 FeS, solid. And then 7 over 2 times 2 gets rid of the 2, so that gives me 7 oxygen atoms to give me 2 iron oxide plus 4 sulfur dioxide molecules. And if I look at the mark scheme, you'll see that they do prefer it that way, but they also say accept any other correct ratio. Okay? To be on the safe side, try not to get, what do you call them? Fractions. Try to make them whole numbers, but the reason why I always do it this way is because it's easier to get rid of the 2 in the denominator when I multiply everything by 2. Okay, next question. Deduce the change in the oxidation state of sulfur. So here I started off with iron sulfide. So here it's asking me to deduce the change of oxidation state of sulfur. So first of all, we had FeS, and then we ended up with SO2. So I need to figure out what the oxidation state of sulfur is here and what the oxidation state of sulfur is here. This one is easy because it's +2 and sulfur here is -2. For this one, it's a bit trickier, so you need to remember that the addition of all of the charges must equal to the overall charge of the molecule. Now, I know here I have no charge, so it must equal to 0. So let's assume that the oxidation state of sulfur is unknown, so we'll make it equal to X, plus I have 2 oxygen atoms, which is -2, okay? And the overall charge for the sulfur is 0. So then X minus 4 is equal to 0. So then the charge of sulfur and sulfur dioxide is going to be +4. So this is why covalent bonding is different to ionic bonding, because with the ionic bonding, I know the cations are always plus and the anions are always minus. But when we have covalent bonding, it depends on what's being basically bonded together by the sharing of electrons, and the oxidation state will basically be equal to the overall charge of the molecule. So here I know that I've gone from -2 to +4, okay? And that's the change, it's from -2 to +4. So if I go here, you have different ways of saying what is the change. You can say that the change is +6 because you go from -2, -1, 0, 1, +2, so +1, sorry, +2, +3, +4, which gives you the +6 change. Or you can just say that it's gone from -2 to +4. You can say that it's gone to 6. You can accept -2, 4, but you cannot write 2 minus 2, 4 plus. It's really important to put the charges as such plus and then the number. Because when we write it as 2 minus or 2 plus, this is we're looking at complexes. So always put the charge and then the number. The next question asks, suggest why this process might raise environmental concerns. So when we're looking at these kind of questions, we're trying to think about the products that we're producing and why they might be harmful to that environment. So from memory, the products that you're forming are iron oxide and sulfur dioxide. We know iron oxide is not much of an environmental hazard, but sulfur dioxide is. So first of all, you need to specify what product is actually causing this harm, and you say that it's sulfur dioxide. And the harm that it's causing is that it causes acid rain. And as we know, acid rain is both harmful to us and the environment around us because it is a pollutant. So it causes acid rain, okay? Another reason that sulfur dioxide is harmful is because if you inhale its dust, then it's going to cause respiratory problems. So if we go to the mark scheme, you can see here that they want you to mention exactly that it's the sulfur dioxide that's causing acid rain, or that the dust, okay, causes respiratory problems. You cannot just say that it causes respiratory problems or that it causes acid rain. You have to specify that it's actually the sulfur dioxide. Next question asks you to explain why the addition of small amounts of carbon to iron makes the metal harder. So you have to think back to the metallic properties. If you remember that any metal, the way that it's laid out is that you have cation centers, okay? And between the cation centers, you've got the electrons swimming around them. Now, the fact that they are of the same size means that they have a regular arrangement. Okay, so if I draw it a bit better, you've got the iron, okay, and they've got a regular arrangement because they're the same size. So there's going to be exactly the same breaks in between them, or the holes, or whatever you want to call them, which allows them to slide past each other. And because they slide past each other, that means that they are malleable, and then you can bend them and stretch them and do all sorts of things without actually breaking them. Okay, so if I have a regular metal, okay, it has a regular arrangement. However, if I have this iron now, the metal, okay, so this is the regular arrangement that you have, and then I put carbon atoms between them. What we know is that the carbon atoms are much smaller. So what they do is that they're going to fill the gaps between the iron metal, okay? And so this prevents them from sliding past each other. And the fact that I stopped it from sliding past each other makes it harder. So if we look back at the mark scheme, this is exactly what they want you to say. It's either that it disrupts the regular arrangement of iron atoms or ions, or that the carbon is different in size to the iron atoms or ions, which prevents the layers or the atoms sliding past each other. Now remember that this is 2 marks, so that means that you need to talk about 2 things. Either this point, which is disrupting of the regular arrangement of iron atoms or ions, or that the carbon is different in size to the iron atoms or ions. But you must say in either case that it prevents the layers or atoms sliding from it over each other, which makes it harder. Moving on to the next set of questions. Magnesium is a group 2 metal which exists as a number of isotopes and forms many compounds. State the nuclear symbol notation XAZ for magnesium 26. As I keep saying, that you need to make sure that you know how to break apart the information you're given in the introductory statement as well as the question. So here it's telling you that magnesium is a group 2 metal, okay? Knowing it's a group 2 metal, I automatically know that it's going to form a +2 charge and exists in a number of isotopes. And the word isotopes means that I have an element that has the same atomic number but different mass numbers. State the nuclear symbol notation XAZ for magnesium 26. Okay, so it's really important to recognize that when you read something like magnesium 26, this is actually saying the name of one of the isotopes, magnesium being the name of the actual element and 26 being the mass number. So since I know that that's the mass number, then I know that A is equal to 26. Another important thing here is that the question is asking you to state. State does not mean to explain anything. You just write down what information that you have. So A is 26, X is Mg, and Z is the atomic number for magnesium, which is 12.
Next question, mass spectroscopic analysis of a sample of magnesium gave the following results. Calculate the relative atomic mass, AR, of the sample of magnesium to 2 decimal places. It's really important to pay attention to what the question is asking you. Is it asking you to determine the answer to 2 decimal places or to significant figures? In this case, pay attention to the decimal places. So how do we calculate the AR? To calculate an AR, you need the mass number of the isotope and its abundance. So what you do is that the AR of magnesium is going to be 24 times its abundance, which is 78.6, okay, plus the mass times the abundance of the next isotope, so it's 25 times 10.11, plus the mass number and the abundance of the third isotope, so it's 26 times 11.29. And then I divide all of this by 100 because we're looking at, so we're dividing by 100 because we're looking at the percentage abundance. So if you add up all the abundances, you should get 100, and that's why we divide by 100. So the next step is to actually include it in the, to calculate it in the calculator, and the important thing is that you need to use brackets. Without the brackets, you might run into problems and you get incorrect answers. So it's important when you're laying out, you're working out, you put the bracket 24 times 78.6 plus 25 times 10.11 in its own brackets plus bracket 26 times 11.29 bracket over 100. So when we go and put this into the calculator, you should get an answer of 24.3269. Now the question specifically asks you to 2 decimal places. To 2 decimal places, which means 24.32, but because you've got a 6 next to the 2, then the answer is going to be 24.33. Now remember, the question is asking for the relative atomic mass. Anytime you see the relative means that there is no unit. Okay, so this question does not have a unit. And if you look at the mark scheme here, you see that you will be awarded the first mark for actually showing out the working out. So you have to show the formula, what you've used and how you calculated it. And then the second mark is for the correct answer and to the correct number of decimal places. Now if you just go to the periodic table and just give them an answer, the IB examiner won't accept this. So be very careful when you're laying out your working out and giving the answer to the correct decimal places or significant figures depending on what the question is asking you for. Next question says magnesium burns in air to form a white compound, which is magnesium oxide. Formulate an equation for the reaction of magnesium oxide with water. Okay, so it's not actually asking you to do the equation for the first reaction, but the equation for the second reaction. Okay, so what you need to do is write MgO, which is a solid, and reacting it with water, which is a liquid, obviously, to make magnesium hydroxide, okay, which is a solid. Now with this reaction, you'll notice that now I formed a hydroxide where I started off with an oxide. This is the reason why oxides are basic in nature. Metal oxides are basic in nature. Anytime you see a hydroxide that is linked to a metal, generally this means that it's a base, okay? So magnesium oxide, sodium hydroxide, any type of metal oxide is going to form a base in solution, and that's because when you put it in water, it will form a hydroxide, magnesium hydroxide. So if you look at the mark scheme, you'll notice that you've got 2 ways of actually writing this reaction. Either magnesium oxide reacts with water to form magnesium hydroxide, or that you've got magnesium oxide solid in water forms the ions magnesium 2+ and the hydroxide. Either one is correct. I would always go for the first one because that's the easier one rather than go into the ions, etc. Okay? Next question. Describe the trend in acid-base properties of the oxides of period 3, sodium to chlorine. So always with these kind of questions, they're going to follow it up with an acid-base property. So with the acid-base properties of the oxide of period 3, you'll notice that we start with sodium, then we move to magnesium, then there's nothing there because there's no transition metals in period 2. Then we get aluminium, then we get silicon, and then we get sulfur, and then we get chlorine, and then we've got argon. So we know these 2 elements are going to be my metals. And then moving on from here, these are my non-metals. And we know argon is really not going to be very reactive because this is going to be my noble gas. Okay? So when we look across period 3, we're moving from something that's a metal to a non-metal. This is going to affect its behavior as an acid or a base. Metal oxides, okay? Metal oxides, they are basic in nature. And the reason being is, just as we saw as an example here with magnesium hydroxide, is that they form a hydroxide in solution. This makes them basic. Aluminium oxide is actually amphoteric, and amphoteric means that it can act as an acid or a base depending on what it's reacting with. And silicon, sulfur, and chlorine, they form acids. Okay? So in this case, you've got something like sulfur dioxide, and we know sulfur dioxide forms acid rain, so we know it's very acidic in properties. So when we're describing the trend in acid-base properties of the oxides of period 3, we have to think of exactly that the metal oxides are basic in nature, then they become amphoteric in terms of the aluminium oxide, and then they become more acidic as we move across the period, and then obviously argon is going to be non-reactive. So how do we answer this kind of question? Exactly as I explained it to you, you've got 2 marks, so you need to do 2 points. You're moving from basic to acidic and through amphoteric, okay? You can say that the words alkali or alkaline for basic. You can use oxides of sodium and magnesium are basic, and oxides of aluminium is amphoteric. You can use the oxides of nonmetals, silicon to chlorine, are acidic. You can't just say that they become more acidic, you have to be specific. What is acidic, what is amphoteric, and what is basic? Okay, next question. In addition to magnesium oxide, magnesium forms another compound when burnt in air. Suggest the formula of this compound. This question is getting you to recognize that oxygen isn't the only gas that we breathe or is that's in the air. Actually, it's the least dominant. The most predominant gas in the air is actually nitrogen. Okay? So the question is asking you for an ionic compound that is formed between magnesium and nitrogen. Well, magnesium belongs to group 2, like we said before, so this is +2. And nitrogen belongs to group 15, so it's got a -3 charge. So it's just a matter of balancing these ions together. +2 -3 means that they're not balanced, so I assume that there's one of each. So 3 times 1 is 3, and 2 times 1 is 2. So then the formula is going to be Mg3 and 2. And if you look at the mark scheme, you'll see that this is exactly the answer that they want, is Mg and 2. You can also think about other things that you can form in the air, like magnesium oxide. Okay, when you have magnesium hydroxide, you can have magnesium and nitrate, magnesium carbonate, but the simplest one to have here is actually the magnesium N2, which is a magnesium nitride. Next question, describe the structure and bonding in solid magnesium oxide. Okay, so this question is getting you to recognize that this is an ionic compound. And with questions like this, they're getting you to think about the definition of what makes an ionic compound. So it's not enough just to say that it contains ionic bonding, you have to actually talk about the structure. So with the structure of the solid magnesium oxide, you have to say that it's held together by electrostatic attractions. Electrostatic attractions between oppositely charged ions, but since you know what these ions are, you can say Mg2 plus and O2 minus. Okay, and this is basically what they're holding them together. You can talk about the crystal lattice, that it's a repeating unit. So anything that basically gives an explanation or a description of the structure of an ionic bond. So if you look at the mark scheme, there's different ways that you can address this. You can say that it's a 3D giant, regular repeating arrangement of ions, that you've got the Mg2 plus and then you've got the O2 minus, then another Mg2 plus, O2 minus, so it's a repeating lattice. Or you can say a lattice of ions. You can accept giant, but don't say giant covalent. It's a giant ionic molecule. Or you can say electrostatic attraction between oppositely charged ions, or electrostatic attraction between magnesium 2 plus and O2 minus ions. Again, they will not accept the answer if you just say that it's ionic without actually describing what an ionic bond is. Last question, propane and propene are members of different homologous series. Draw the full structural formulas of propane and propene. Here you have to be careful with the suffix. Ane means an alkane and ene means an alkene. So propane is just made up of single bonds, and ene means it's made up of at least one double bond. Okay? And the fact that it has prop in both cases means that I have 3 carbons. So I will draw the 3 carbons first. Okay? For both of them. But for propene, I will have a double bond for one of them. Okay? And then the rest of it, because it's just a regular propane and regular propene, that means the rest of the molecule is just the hydrogen atoms that are surrounding the carbon atoms. So for propane, it will have the structural formula of this. And for propene, you have to be careful with the double bond. I've already used 2 bonds, so therefore I need 2 more. For this carbon, I have 1, 2, 3, so I need 1 more hydrogen. And for this carbon here, I have 1, 2, 3, and 4. Okay? And that's the full structural formula. So be careful. When they ask you for the full structural formula, you have to draw the whole thing. You cannot use a skeletal diagram, and you cannot have a condensed structure.